Today we're going to be learning about minerals. What is a mineral and the different characteristics that make a mineral special. First, let's talk about how we know if it's actually a mineral. Well, the first and most important is it's naturally occurring. That means it occurs in nature. It's not man-made. If man makes it, it's not a mineral. Okay? The next is it's inorganic, which means it's not living, it's never been living, and it doesn't contain anything that is living. It doesn't contain carbon. So it's naturally occurring, it's inorganic. It also has a definite chemical composition. They're composed of a specific set of elements, and each one is very specific to the mineral itself. It has definite physical properties, such as density, luster, hardness. Okay, and those can be used to identify exactly what mineral it is. And finally, it is solid. There are no liquid minerals. So again, let's go through. It's naturally occurring. That means it's not man-made. It occurs in nature. It's inorganic. That means it's not living and it's never been living. It has a known chemical composition. That means we can tell exactly what elements make it up. It has definite physical properties, density, luster, hardness, and it's solid. So here are a few examples of minerals. We've got quartz, aluminum, copper, graphite, that's what we use in pencils, and feldspar. We use that a lot in pottery and glass and cement and glue. So here's just a few examples of different kinds of minerals. So now that we know what minerals are, we're going to learn about how we could identify a mineral and what mineral it actually is. You can do certain tests, and we're going to talk about those tests to actually identify what mineral it is, and that's what scientists do use to identify one mineral from a different mineral. The first thing we can do is look at the color. That's how it looks, but many minerals come in more than one color, so this is not the best way to identify a mineral. Just because it's purple doesn't mean it's a quartz. A quartz can be purple, it could be pink, they could be white. Okay, so many minerals come in lots of color, but the color is a way to identify it. You say, what color is it? So which of the following is gold? If we were identifying by its appearance, they both look gold, don't they? The next thing we're going to talk about is streak. The streak is basically the color of the powder, that mineral in powder form. If we were to rub it against something or pound it and crush it up, it's the powder form. And it might actually be different from the color of the actual mineral. It's when a mineral is rubbed across a piece of porcelain tile, it'll leave a streak behind or a line of powder. You can see here, this mineral was rubbed across a porcelain tile and it left a red streak. Here, this mineral was rubbed across a porcelain tile and it left a yellow streak. So if we're recording information, we would record that the first one had a red streak and the second one had a yellow streak. And that would help us determine what kind of minerals these are when we put it together with the rest of our tests. Remember, this is just one test among the many that we do. The next thing we're going to look at is luster. Luster is the way a mineral reflects light. That means how it sends it back to our eyes. So it might be metallic or shiny, or it could be non-metallic, kind of dull, waxy, greasy, pearly looking. You can see here it's very metallic looking, while this one is not metallic looking. It's a little more dull. it's not quite as shiny, a little waxy looking. Again, luster, again, is just one of the many ways when we combine that with color and streak and now luster, we're getting closer and closer to being able to identify exactly what mineral this is. We're going to talk next about the two ways that a mineral can break. The first one is called cleavage. It's when a mineral breaks consistently along a smooth, flat surface or parallel planes. So when I break it, it's very smooth on both edges where it breaks. Mica is a really good example of mineral with cleavage. When we break it, it flakes off and it's like little sheets. Both sides are very smooth where it breaks. You can see this one would break in a smooth line also. So if I broke that, it would have cleavage. Both pieces that break off would have clean, smooth surfaces. Here's some more examples of things that break in cleavage. They don't always have to break the same way like mica did in sheets. There could be cleavage in one direction, like muscovite. Okay, it's kind of peeling off a little bit like the mica. You could have cleavage in two directions like feldspar. You're going to have up and down and across. It's going to break in those smooth lines both places. You could have cleavage in three directions like halite. Again, it's going to break all over the place, but it's still going to be smooth breaks. And finally, you could have cleavage in two directions like calcite. So you can see there's a lot of different ways it can break, but it's still breaking on smooth, flat surfaces. The second way that a mineral might break is called fracture. Fracture is when it breaks along random, uneven, rough, jagged surfaces. This is where you might think of the most when you break things. So the quartz is a great example of a mineral with fracture. When we break it, there's no smooth, flat surfaces. It's very rough, it's very jagged, the break is very uneven. All right, our next test is hardness. This is not necessarily how hard a mineral is, but how easily it can scratch or be scratched. So can I scratch it easily with my fingernail or a penny or a nail? Or can I use it to scratch something else? We measure hardness on something called the Mohs scale. So if it's not very hard, if I can scratch it with my fingernail and a little bit of the powder comes off, it would be considered a hardness of 1, like talc. Talc is probably the least hard of all the minerals we're going to look at. At the very opposite end would be a diamond. A diamond is super hard. It scratches everything and nothing scratches it. And there are quite a few in between. So it goes from 1, which is the least hard, and moves all the way to 10, which is the most hard. And some things can scratch other things, like topaz can scratch quartz, but quartz, because it's lower, can't scratch topaz. So you'll see things that are softer can be scratched by things that are harder. We talked about one of the characteristics was its definite chemical composition and its crystalline shape. This describes the orderly arrangement in atoms that determines the external shape. So it's all those things inside one of the minerals that when we put it all together, it makes the shape. When minerals have time and space to grow in their crystal forms, they grow into beautiful, regular shapes that are easily recognizable. So topaz, you can see, has a definite shape. Quartz, its structure, if you looked under a magnifying glass, has a very distinctive shape. Diamonds and muscovite, they all have orderly arrangement of atoms which give them their crystalline shape. When they put all together, it makes the mineral. So in addition to those basic ways we just talked about to identify a mineral, there are other ways that we can use to help us identify minerals even more accurately. Taste, although we never put any of our minerals in our mouth to taste them in a lab. Odor. Some have a very distinctive odor. Some smell very strongly of sulfur or other things. The reactivity to acid. If I drop some acid on it, does it bubble? Fluorescence. Is it kind of glow in the dark? So if I put a black light on it, will it glow or emit a glowing look? Texture. So how does it feel? Is it rough? Is it smooth? The texture of it. Then we have radioactivity. Is it radioactive? Does it emit radioactive waves that would be dangerous to us? And finally, magnetism. Does it act like a magnet? Will other things stick to it that are iron? All right, so let's first look at taste. Some minerals do have a distinctive taste, but do not lick the minerals. There are minerals that are poisonous, so don't use taste as a way to identify a mineral in one of our labs. An example might be halite. It tastes like salt, so it's very salty. The next way we might is odor. Okay, and if we're smelling it, again, we want to put our nose close to it and waft. Remember, do our hand and wave our hands so that we bring the smell to us. We're not putting our nose directly on the mineral itself. And some have a very distinct odor. Some smell very strong, some have no smell at all. Minerals that contain sulfur, okay, smell like rotten eggs, really yucky. And again, always be careful or cautious. You don't want to put your nose right up to it. You want to wave your hand in front of it and bring that smell to you. Don't go to the smell. Sulfur, yuck. All right, we have our reactivity to acids, or how does it react to acid? This test describes how minerals react to acid. For example, carbonate minerals react and bubble when acid is dripped on it. Again, be very careful when you're performing a test like this. You're actually working with acid. You can see here, acid was dropped on this mineral and it bubbled up. It didn't just sit there like water might have. Fluorescence, a really fun one. So some minerals emit a visible light when an ultraviolet light is shown on it. It can come out in various colors and it looks just pretty cool, like it's glowing in the dark. That is its fluorescence. Texture is really just how it feels when you touch it. Is it coarse? Is it rough? Is it smooth? Is it slippery? An example would be talc, has a very slippery feel. While this is a way to test a mineral, kind of like color, it is not the most accurate way. But it is one of the many ways that you can add them all together to make sure you're really identifying it the best that you can. So radioactivity, not good for us. It's when a mineral emits radioactive waves in the form of gamma rays that can be detected by a Geiger counter. We have our Geiger counter, and then we have some radioactive minerals. These are ones you do not want to be around unless you have the proper equipment and safety gear. All right, magnetism is always a fun one. It's when a mineral is attracted to a magnet, or it's attracted like a magnet. When things near the magnet, they will attract or stick together. So an example might be magnetite. It acts like a magnet. You can see there's some magnetic properties because those nails are on it, our iron shavings. When we put staples near it, they stick to the mineral because this has a magnetism. It has a magnetic property. So on your notes now on the right-hand side, I want you to get in a group and I want you to try to answer those several questions and see what your group comes up with.